Okay, for those of you who are still with me and did not just jump to the practical parts of this course, I will try to give a very brief summary of a couple of advantages that a visual tree representation has. Now, I'm not only doing this for completion, for to be complete with the course, or to give you a complete overview, or just to give you more theory that you can throw around somewhere. Uh, the actual idea is, I think, or my actual goal is that you kind of get into the mindset that you need to have for Unity's system, for the UI toolkit system, because, and I don't mean like mindset like in a philosophical determination point of view. I just mean a specific look on your UI, because those things will have consequences in your work, particularly working it with Flexbox, to think about the elements as kind of parent-child relationships and stuff like that. Once you grasp this, and this is kind of your mental model of those things, you will have a more easy way and more easy work, I think, than when you kind of fight with it and try to represent it in a different way. And also, I think it's a kind of pretty natural representation, actually. But let's just see what consequences this actually has. Now, one point that I want to make is that it is actually pretty efficient to represent it that way. And I mean that in a computational way for once, but also in kind of your workflow way, that you have efficient ways to get to certain elements. Now, for example, if you would say that you want to have all the children of the red element for some reason, and all the children should get an icon or something like that. Now, in the previous way, in this unstructured way that we had, you would not even have the terms to express something like that, based on the way you saved your files, because you couldn't say that something is a child of something or something is in something because you didn't represent it. Now, with our visual tree, what we can do is we only say, okay, in some way, I don't know, with some ID or something, get the red element, and now just traverse all the children. We can easily do that because we have all this information basically saved in our hierarchy or our visual tree view. And now we could easily say, okay, give every element an icon. So in that sense, it's very efficient in terms of thinking about it, but also, of course, computationally, you don't have to do things like go over all elements and do something with them. But once you know, okay, I have the red element and I want all of its children, you just give the system kind of your red element and call some function that says, look over all children. And that's trivially easy to do because you just take the elements that are kind of beneath the red element. Okay. Another thing that kind of automatically happens once you start working like that is you might have the idea. Sorry, I'm just waiting for this sound to pass. Okay, you might have the idea, okay, wait a second. I'm having the whole tree, but maybe I like some part of the tree and I want to reuse it for some other UI. Now, that's also trivially easy to do because you now just say, okay, I'm basically cutting this tree at some point. I just want to have the red element, and that's the perfect, correct representation of just the red element. We don't really care that it was previously attached to this other structure. We now have just the red element, and now we could have a new UI that for now only has a gray node, and we attach the red element twice to it, and that would be a perfectly correct representation of this new UI. And you can imagine that you can do that however often and however deep you want. You could now take this whole element and attach it to a different tree. And that kind of never ends. And that's sort of the beauty of this kind of trees. Okay, so that's the second point. It's a large point because that's what you actually do in Unity when you do your layout templates and that you reuse later. And we will see that in action a couple of times through this course. Now, the next thing that the visual tree representation helps us to do is something that we didn't talk about a lot yet, because so far we looked at layouts that were kind of nicely structured, where everything had its place and there were no overlaps or something like that. But oftentimes that's not the case. Oftentimes there are overlaps. Like when you have a modular window, or you want to have something that is just some special nice visual element that is flowing around the screen, or you have some fixed nav bar or something like that. All those elements you might want to put those elements over or under some other element. And again, in our unstructured representation, it would be hard to say. You would have to kind of manually decide, now what elements do we want to have above and what elements do we want to have below. A tree structure allows you to have a kind of automatic definition where you know why an element is over a different element and why it's looking like that and not like that. And we will talk about that, what that definition is and how that works in Unity. However, it works because we are using this visual tree representation. And the last point that I want to make is kind of a summary of the other points and like the general thing that I'm trying to the general point I'm trying to make throughout the last lessons is that it is just a good way to think about your UI. So even if it would not be used kind of under the hood in the technology, it would be a good idea to use it in your thinking. And you should use it in your thinking. It will make your work easier probably. Now, you could discuss about whether there are other representations that might even be better. And if you would have, I don't know, something like a collage or something where those elements are arbitrarily mixed around, maybe this would not actually be the best representation for it. But since we are talking about UI projects that have a certain structure, that always tend to have windows containing other windows, containing buttons, containing lists and stuff like that, it is, I think, the best way to think about those UIs as a visual tree, and it will help you in your work. So just see what happens if you are if you're a web developer for 5 or 10 years. You're probably saying, Jesus, like, why are you pointing out the obvious? It's like, that's why, for example, HTML does basically the same thing. There it's called the DOM, the document object model, and it works for, I don't know, 30 years or something like that. And it has still not changed, and there's probably a good reason. There's probably a good reason why it's still present. But if you are not coming from that, if you haven't ever used HTML, for example, and you're using different graphical projects, graphic software that might not have that kind of representation, that might be a little shift in thinking for you. But I encourage you to actually try to embrace it and start thinking about UI in that way. And also, I think it's actually a kind of natural way. So hopefully most of you guys won't actually try to argue with me. Although if you have other ideas, make some suggestions, write them in the comments. I'm actually interested about other ideas how you could represent UIs generally. That is the way Unity uses, and that is the way we will use for the rest of the course, and how the other tools in UI Toolkit, like Flexbox, for example, use and represent UI. So that's enough for this video. In the next video, we will actually make this little thought step that I was speaking about in the beginning of the section, that how do we get from the visual tree representation, which we now extensively covered, to the actual UXML files, and we will do that finally in the Unity editor.